to the Extraordinary Technology Conference 2016. As we begin this session, which is our Saturday morning session, Extraordinary Concepts, we're going to be hearing from Richard Blankenship. Richard comes to us from a background in science and mathematics, and he entered this field of alternative technologies because he resonated with and thought outside of the box. This led to an understanding or an introduction to Tetryonics, which he is going to be presenting to us today. So I'd like you to give a warm welcome to Richard Blankenship.
Thank you, sir. Well, good morning. I hope everyone's had their breakfast, morning coffee. Obviously, what I'm presenting this morning is a unified field theory of mass, matter, energy, in all its forms, but it comes in a geometric form. Energy is an equilateral triangle in this theory and in this interpretation, reinterpretation. You could also say it's a re-enunciation of many of the long-held principles of science that over time have been confused. So to get right into the equilateral triangle, energy is equilateral, and there is an electric field component and a magnetic dipole arrangement that we're going to explain a little bit further as we go along. But what's missing is this geometry. Without the rigidity of this equilateral energy, science or in mathematics alone, using pure mathematics, is a little bit going beyond their bounds. The entire Tetryonic material is driven by the rigidity of geometry. So we can look at this shape, and then we start to build the equilateral tile of the universe. This is the only shape we're using in Tetryonics. If we can't explain how something works in our physical universe using this shape, then we go back and we re-look at it, re-examine our triangles and our interrelationships. And thanks to an individual named Kelvin C. Abraham, who developed the Tetryonic materials starting in about 2008, I am standing on the stage presenting it to the first live audience. Now, this material is freely available. We're spreading this information wide throughout the planet because we feel that scientific advances should be shared freely for a community of people such as yourselves who do experimental work. So I'm briefly going to talk about the standard model and explain another conundrum. So the standard model is building particles and understanding how the subatomic worlds work, but what's been missing from that model is this tangible geometry to develop our math. The current math relies on Gaussian formulations, where this has 4 pi geometries right here. They're assumed to be spherical, like planets and stars, but what we're saying is that the spherical model of the electrons and charges is wrong. It's been mistaken for spheres, but what's really happening is the pi geometry of energy. We can call each triangle a pi, radian, but then the tetrahedral form, a Platonic solid, is the quantum of matter. So you get down to the pure mathematics, and a sphere and a tetrahedron share the exact same mathematical principle. Therefore, pure mathematics is insufficient, and we need a geometric reinterpretation to really hone in on what we're trying to describe. This entire theory is just all around the tessellation or joining together of these equilateral triangles that create all the quantum mechanics that we formulate our math on. I'm going to introduce a few quotes that help me to understand this. I hope it helps you. To my mind, there must be, at the bottom of it all, not an equation, but an utterly simple idea. And to me, that idea, when we finally discover it, will be so compelling and so inevitable that we will say to one another, "Oh, how beautiful. How could it have been otherwise?" And the next quote by John Archibald Wheeler is, "Someday, a door will surely open and expose the glittering central mechanism of the world in its beauty and simplicity." Then Erwin Schrödinger, he states that this new idea is what is permanent in these ultimate particles, or small aggregates, is their shape and organization. They are, as it were, nothing but pure shape. That's what this theory is doing for us. It's going to reinstate an intuitive feel to physics, mathematics. Concepts of quantum mechanics are going to be re-expressed, reinterpreted. There's a little bit of a brain rewire that happens as we become familiar with this. I came to Tetryonics 2012, and here it is 2016, and I can tell it's going to require another 4, 10, 20 years of my time to fully understand what's happening. But at this stage in the game, this introduction is simply scratching the surface. And again, all the materials are available online. You can meet with me at the end. We'll give you the website addresses. We're always available to answer your questions. To date, Tetryonic theory has been applied to quantum mechanics, electrodynamics, chemistry, and cosmology. What's not mentioned here is it's also been applied to music, biology, and mathematics itself. We have a bottom-up approach with Tetryonics because we only use the equilateral triangle. Mathematical expressions are emergent from this geometry. The universe isn't mathematical in nature, it's geometric in nature, but we developed the language of mathematics to help us understand and express further. So here's just to bring you into the equilateral geometry. What we have on the left here, we call a plus charge. You'll notice there's a north-south dipole arrangement, and on the right, we have the same quantum coin, it's just the opposite side. So if, could I get the projector for just one brief minute, sir? This is just a visual aid. This is just a visual aid. But we're just talking about a quantum coin that has two sides. There's a plus charge, there was a minus charge. But what's happening is the only way to tell the difference, back to the slides, sir. The only thing that makes it different between a plus and a minus is the north-south pole arrangement, and over here a south-north arrangement. As you begin to rotate these triangles in space, you begin to create an intuitive understanding, and you can build these things. You can create a tessellated field, the tile of energy itself. Any unified theory must have electric and magnetic field components explained simultaneously, and that's exactly what this does. We're going to get into the particulars a bit later, but this geometry right here also reveals the 90 degrees phase relationships between E fields and magnetic fields. Now, I want to introduce the concept of omega, because omega is the equilateral geometry. And omega in Tetryonics is quantized angular momentum. It carries with it the units of square meters per second. It's not to be confused with a physical rotation or angular momentum as we understand it at the macro scale. It's actually the shear geometry that we're looking at here. The alpha constant is just the linear forces between charged particles. So we have an alpha and an omega, a theory that encompasses everything. Again, it's very important to distinguish the difference between mathematics as a language and geometry as the actual grammar that guides the language. And we must choose wisely if we are to understand nature and how it works. So this is kind of funny. It's supposed to be funny. Mathematics is mental abuse for all those who seek an understanding of geometric physics that underpin nature. There's some key insights in this image. What we have over here is Max Planck's quantum levels. So obviously, Tetryonics embraces the ideal of the discrete quanta, the building blocks, finite energy. Basically, we're counting quanta, but we're putting these quanta in equilateral arrangements, forming larger and larger equilateral fields. And as we add more quanta, we obviously increase the force as a result. So on the left, I want to point out, we're talking about transverse bosons, and on the right, we're talking about longitudinal photons. Max Planck and Albert Einstein were studying the same energy. They were just doing it from two different perspectives. And this puts it all into perspective. And in some respects, you can call this the 0-point field. And Einstein even said this in 1913. that the 0-point energy of a simple harmonic oscillator is h frequency divided by 2. We're going to get into this in a few minutes, but a photon of energy is not a quantum. It's actually two triangles back to back. A plus here, and then another triangle down here would be a negative. So we have a neutral light particle, but we have to say it's a dual boson pair. If you take a full wave photon, where you have two of these simultaneously back to back, that's a 360 degrees unit circle. But what's actually happening is we call those individual triangles pi radians. And as we know, 2 pi is 360 degrees. So we're reformulating our understanding, and literally you divide h frequency divided by 2, you end up with one of these triangles, half of the photon. So just to reiterate the point, all of the mathematics that comes out of the equilateral triangle, but that's the nature of the matter. And for some reason, the human mind has missed it for a very long time. We're going to try to put physics and mathematics on a course correction. Have a little thing. So, along the source of mystery, the revelation of geometry as the basis for the physical constants reveals the relationships between matter, energy, momenta, charge, and all the other physical constants. What's constant about our physical constants is the geometry. So you can start to understand the importance of kind of how the universe is fine-tuned or designed. Again, I'm just reiterating the fact that we have two sides of the same quantum coin. If I had one coin right in front of me and I'm looking at the positive side, all of you would be noticing the negative side. It's kind of the yin and yang philosophy in one respect. But what we're going to do is we're going to tessellate these. We're going to tile these and form larger and larger equilateral fields. Just a point before I move into that is that many scientists find it hard to believe that the investigators who constructed the currently accepted theories could have made so many mistakes. It should be emphasized, therefore, that the profusion of conflicts between present-day ideas and our findings does not indicate that the previous investigators have made a multitude of errors. What has happened is they have made a few serious errors that have led to a multitude of consequences. Energy is the triangle. What we're representing down here in the lower left is mass energy, and hopefully you can see it, maybe not, but there is a circle, a light second circle. A way to understand this is the famous equation E equals mc squared. If we do a simple algebraic manipulation and take the c squared to the other side of the equation, we have energy divided by light seconds equals mass. So as we measure energy per time, we have mass. That's how we can rationalize out some of these things. What's missing in modern physics is an understanding of matter as a tetrahedral topology. This is also got a circle around it, but this is a light seconds squared, or a c to the fourth coordinate system. Over here with mass, we have c to the second coordinate system. So this is what we've been missing, ladies and gentlemen, and we hope to show you the connections that come out of this are vast and far-reaching. But this is the major launching point of Tetryonics, is this quantized angular momentum. What we need to realize here is that it carries with it the units of square meters per second. And when you combine this with mass, square meters per second is Planck's constant. So we can also say mass omega as abbreviation for Planck's constant. Again, there's no physical spin, flux, or curl at the quantum level. It is the equilateral geometry that we're looking at and interested in. Again, 0-point fields are the individual triangles. And as you can see, the geometry of energy dictates that there are no monopoles. The attempt to use pure mathematics to devise a monopole understanding is just an attempt to flush out some more possible physics understandings, but according to Maxwell, Gauss, and a few others, we're always going to have a magnetic dipole. It's always going to happen. It's always there. So we can go on here, and begin to pull in Max Planck with the Einstein. Again, Einstein's the photons, so we're going to have two bosons to make a photon. I'll show that in a little bit. But quite literally, you divide that by 2, you end up with one boson. That is our zero-point field. There's no virtual particles that come in and out of existence. It's just the geometry's been missing. There's no oscillation like the harmonic oscillator. It's really just either side of the same Planck quantum coin. And we have to understand where the south-north arrangement would represent a negative. And in this case, you could model it mathematically as a anti-clockwise inductive loop. So bringing in the idea of ideal inductive loops, a positive is always going to be modeled as a clockwise. This is just a good mathematical way to help electrical engineers get brought into the understanding of an ideal quantum inductor. And so when we bring two of these triangles together along the magnetic dipole edge, so imagine another triangle here, we literally have two inductors, 1-to-1 ratio, so a photon of light can be looked at as a 1-by-1 transformer. Just another way of explaining it. The Tetryonic materials, as they developed, there are 3 laws. And we're going to spend some time looking at the first one. But all squared numbers in physics are equilateral geometries. Really, we would like to drop the term square because as these triangles tessellate, you develop the square number arrangements. But the English vernacular is confusing. And so when you think square in Tetryonics, don't think of a 90 by 90 square. You don't want to do that. You want to understand that we're counting quanta that build up into square quantities. Second law of Tetryonics is energy in all its geometric forms seeks equilibrium, whether it's the Planck quanta, the bosons, the two-dimensional radiant EM fields, or after they formed the 3D tetrahedral matter topologies, they all seek equilibrium in whatever form we find them in. The third law of Tetryonics states that there are no infinities in nature and that energy seeks equilibrium eternally over time. So there are no infinities, but there's a distinction between infinities versus eternities. Energy cycles through its various forms, its radiant forms, its matter forms. We collapse the matter topology inside of stars, and it's big recycling. It's like the universe breathing in and out over billions and billions of years. Okay, a very important point before we really get in is that Albert Einstein was not a proponent of quantum physics because it was fuzzy. So there's this notion of fuzzy dice. But what I'm going to show here in the next slide is many, many mathematical relationships that develop from the equilateral tile. So Albert Einstein said that God does not play dice, and we would agree. So within this single shape, we have odd-numbered bosons running across the rows. You'll see the odd numbers running down the left side. 1, 3, 5, 7, 9, 11. You add these together, 1 plus 3 is 4, is a square number. 1 plus 3 plus 5 is 9. So just to do it quickly, 1, 3, 5, 7, you add those together, 16. So to say that with English, we say the summation, successive summation of odd numbers results in square numbers. But again, we're not talking squares, we're just talking total quantities here. So when you have a base 10 triangle, you have 100 total triangles, but you have a square root, an intuitive square root understanding developing. Again, this restores intuition to physics and mathematics. And the reason I bring up Einstein and God does not play dice is because the normal distribution, the bell curve, is also represented within this one shape. So looking at the longitudinal direction, we have 1 boson, and then 2 bosons, and then 3 bosons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's where the statistical probabilities of quantum mechanics, the bell curves, come from. So it's all there. And there's nothing fuzzy about it. It's fully deterministic. It's a little bit difficult to wrap our heads around upon the first glance, and there are many layers to Tetryonics that are not immediately apparent. But we also need to realize that the Tetryonic materials is color-coded. You can look for the pink arrows, for instance, to understand what our linear momentum is about. These are the mass-velocity equations, and then if we had a mass symbol here and velocity squared here, we would realize that there are 100 Planck quanta to give us total energy. Again, we're counting quanta, and we're showing that the tessellated tile gives us more information than pure mathematics ever has. It's not to say mathematics is wrong. It's to say we need the equilateral geometry to help us fully understand what is possible and what is not possible in math. Again, this is a different understanding of the quantum probability distribution. If we only had 4 triangles, we have a bell curve of 1, 2, 1. But we can continue on to 9 triangles or 16 triangles, and the same pattern develops. And that's kind of expressed down here. So just another way of showing the same thing. Okay, what's important about this slide is we actually have a geometric expansion. There's nothing that prevents this from going to larger and larger v squared, or as a result, larger and larger forces, velocity squared, running up the apex of the triangles. So again, the tessellated tiling of the universe. Look at these equilateral coins as two-dimensional sheets. They're just thin pieces of paper. They only develop tetrahedral topologies in standing wave form when the situations are right. So the quantum of matter is a tetrahedron. The tetrahedron has been missed in collider experiments, mainly because they have the exact same charge-mass ratio as leptons and sometimes some other quarks. So the tracks that they map out in the bubble chambers are mapping out the same tracks. So CERN can't really identify the individual quantum of matter just yet. We're working on it. We're hoping to get there in time. I guess the main trick to do there is if we could measure the linear momentum of these particles as they're trapped in the bubble chambers, we could do an analysis on their linear momentum and begin to differentiate between tetrons, leptons, quarks, and add precision, add a quantum Hubble telescope for the quantum world. Again, we're moving into the probabilities as expressed by the bell curve. This is just for the mathematicians out there that understand the equations that are resultant from the geometry. With Tetryonic theory, it's great to be aware of the math, but being a math expert, a mathematician that just understands all of the possibilities of infinitesimals and sequence and series, it's not necessary. And about 90% of all the quantum mechanics you can do is just basically playing with triangles of energy, forming them into tetrahedra, building them like little Lego blocks. First graders and second graders will be able to literally take a tetrahedral dice, form quarks, form electrons and protons, and get more information about the system than the mathematics can explain to date. When I first came to this, I was very excited because obviously when we look at Pythagorean theorem, we always see this representation. But now that we know that square numbers are equilateral geometries, this is just as valid. A base 3 triangle has 9 units. A base 4 triangle has 16 units. A base 5 triangle has 25 units. And again, it's just another way of looking at things that I never saw until I was in my 30s. Never saw that, but it's just as valid. The reason I want to point this out, the triangular numbers that came about is the Pythagoras Tetacris. They focused on the dots. So there's just a dot there, there's a dot there, there's a dot there. We just keep on going, and that's where these numbers come from, 1, 3, 6, 10, 15, 21. But twin triangular numbers, when you add 1 plus 3, you get 4. When you add 1 plus 3 plus 6, you get, twin triangular numbers, 3 plus 6, you would get 9. So twin triangulars here, 6 plus 10 would be 16. Just more examples of the mathematics that develop. But the Tetacris was focused so much on the points themselves. What we need to do is focus on the scalar areas that the points map out. The triangular numbers conceal a simpler physical reality. And you're looking at it. This next one's kind of mind bender. Cubed numbers, integer sums to square numbers. So if you cube 1, you have 1. If you cube 2, you have 9. Or cube 2, you have 8, but 8 plus 1 is 9. You cube 3, you get 27, but 27 plus 9 is 36. Pattern continues indefinitely. Geometric expansion. It never changes. It's unbelievable when I began to wrap my head around all the connections, and this is, again, we're scratching the surface here today. Here's another example of a unification that's happening with tetryonic materials. We've got the forces of Newton, We've got the total energy of Leibniz. He was the first to describe energy as scalar waves. So we can call these scalars, pi-radian geometries. And then Abraham comes up with the tetrahedral topologies measured within a c to the fourth coordinate system. So we see this right here. Here's a great point that I need to point out to everybody to increase the learning curve. If we look at E equals mc squared, mass is always lowercase, matter is always capitalized. It is the failure to fully differentiate between mass and matter in physics that has led to some of our problems, something Einstein failed to do. He lumped all of his understanding into what's called a stress-energy tensor. But Tetryonics differentiates, defines the specifics of what mass is. Mass is energy measured per light second in a c-squared coordinate system. Matter is topology. 3D volume encompasses form, encloses space. But what we need to realize about these tetrahedrons is that the mass energies exist only in the faces themselves. There's nothing on the inside of these. We have a null pressure point inside of tetrahedrons. And it is that null pressure point, nature abhors a vacuum. It's that null pressure that explains quantum gravity within each individual tetrahedron of matter. So again, we're reformulating, re-expressing, and restating some things in a little bit different manner. But it's all based on one shape. We just build that shape up, the equilateral tile. We've got scalar energies here, but what we have over here is the quantum distribution, the chopping up, the little bits. But both are valid. But now that we can decide on what we want to use or understand how quantum mechanics develops. So h nu here, the number of triangles gives us the total energy at that point. What really needs to be here, we've gone through some revision processes over the years. This should be a mass over here, and then we can rationalize out the mass velocity squared and the mass v as linear momentum. So again, intuitive understanding of some of these equations. It's like a mnemonics develops. Many of you are familiar with the SOHCAHTOA rules of trigonometry, things where we can do triangular relationships with voltage, current, and resistance. It's kind of the same thing, but it's all-encompassing now. And I wouldn't be able to talk about quantum physics at the level that I'm communicating without having this mnemonic relationship develop from the intuitive grasping. But again, when we look at the quantum side, we have odd numbered rows. There's always sum to square numbers. It never changes. Charge in physics is very difficult to explain. You ask any physicist what is going on or how charge bubbles up from the quantum realm, they're going to have a hard time explaining it to you. Mainly because we're dealing with spheres in modern theory, and there's no way of distributing a plus or a negative, or it's kind of hard to understand how charge develops at the quantum level. What we're saying is that there's a plus. Look at the red triangles here. Those are pluses, and the white ones are the negatives. There's an asymmetric distribution here. Very important concept. The triangles that are pointing up in red, we would call the divergent force vectors. The triangles pointing down are the convergent force vectors. There will always be an overabundance of the divergent here, or in this case, the positive charge. It's this asymmetric distribution of Planck coins at the quantum level that is charge. And officially, the units of charge is mass seconds, for those of you who are looking for the real units of charge and how to rationalize that out. So here we have a negative charged field, but again, there are positive components. So the idea of the law of attraction really needs to be upgraded to the law of interaction. There are bidirectional forces happening within equilateral fields. So over time, hopefully we can update this to law of interaction, and the similars repel and likes, or opposites attract, similars repel, still apply. Those rules still apply, but there's more to the story. It's a little bit, like I said, quantum Hubble telescope, or a Hubble microscope for the quantum realm, if you will. A key point that I want to reiterate is that there is no spin, flux, curl. We draw these circles in the middle to help Electrical engineers understand the concepts of inductive loops, ideal inductive loops at the quantum level. Inductive loops resist changes to their energy state. So it is another way of helping us understand where inertial mass comes from. It's just so many connections. And again, we are only scratching the surface. But here's a really important point I want to make. Again, the color codes of Tetryonics helps us understand the spectral lines. In this case, the pink arrows helps us understand linear momentum, the forces that result as we increase the quanta in any given field. But remember, we're talking about two sides of the same coin. So there's a negative side to this triangle, okay? And now we can fully rationalize the square root of -1 as a physical reality to our universe. A mathematician scratches their heads. What is the square root of -1? Negative times a negative is a positive, a negative, or a positive times a positive is a positive. But all we're saying is that this is a negative charge field, the negative side, and it still has a square root, linear momentum. And Euler's formula, we could have had a Tetryonics hundreds and hundreds of years ago had we understood that Euler's oscillation with changing sine and cosine values actually represents the EM wave. There's some other scientists and investigators over the years that have drawn similar triangles. A Jesuit priest by the name of Athanasius Kircher in the 1600s, during the time of Leibniz and Newton, as they discussed their calculus and began publishing their conversations, and it just got lost. Kircher's version of the equilateral tile had the square numbers over here and the odd numbers here. He named velocity, but he didn't have the electromagnetic field partitions. He didn't have any descriptive understanding. There's over 2,000 pages to the Tetryonics work. This is just 80 slides that I'm giving you today. So again, scratching the surface and an introduction. Some amazing concepts. People might be familiar with Fermat, and his difference of two squares is always an odd number. The geometry shows that that is exactly true. So we have a geometric understanding of a mathematical principle. And here would be the odd number rows that we're talking about as we add. The difference between squares is always an odd number. Why he didn't ever say that the summation of successive odd numbers adds to a squared number is anybody's guess. Just didn't go that far. So here's another example of a mathematical formulation that is emergent from the geometry, Rydberg's formula. So this is the changing of energy states. If we go from an 81-degree energy field and we move to the 1, we have to do 80 divided by 81, and an interesting property develops. The answer is 0.987654321. So we like to point that out and just help people understand that there's much more going on here than might be apparent right away. So we encourage you to look at the materials, to familiarize with the materials, and really take some time with it, because it took me some time. I'm almost 4 years into studying Tetryonics, and every day that I get a few hours to really dig in, I get an aha moment here and there. You should see my Tetryonic notes. I do everything by hand, and I have boxes and boxes of notes. And I'd be happy to share those with anybody after the presentation in the lobby, just so you can look at some of my thought processes that Tetryonics has allowed. Spectral line differentials. This is kind of really interesting because there's something here that nobody else has identified. It's a point of validation for Tetryonics if we can find somebody to do an experimental research on the unnamed spectral line. We do reveal the frequency to that. I didn't bring us into this slide, but we can go into that. We'll be available after the conference, after this presentation. But the spectral lines are just energy jumps between these squared numbered levels. And this one right here has never been named. It's never been identified, never been found. I recommend that when somebody does find it, we call it the Abraham series. Some of you are probably already aware that the equilateral geometry just lends itself nicely to the fractal expressions that we see. This is just a quick, you can cut, chop, do this in so many different ways. But literally what we're doing is just using equilaterals to build larger and larger and larger equilaterals. Okay, I love this one. Modern physics uses a right-angled triangle to try to express its understanding, but quite literally this is a half-truth because it takes two right-angled triangles to create an equilateral. We need to be using this to understand intuitively what is happening at the quantum level and what nature is doing. The space-time coordinate systems, we use C as measure vector forces. We use c to the squared coordinate systems to measure mass energies. And the Cartesians aren't really found in the Tetryonic materials very much. Now we can do a conversion, but what we need to move to is the c to the fourth spatial coordinates if we're going to measure the mass energies of matter, the topologies themselves. So it's really important to know what coordinate system you're in and what you're measuring. Coordinate systems are based on the speed of light, so the speed of light is just a convenient yardstick of measuring energy per light second. We can go into a little bit more detail on this. Again, I'm just hitting the high points, the bird's eye view of Tetryonics to help reduce the mental inertia for getting into the work, spending some time with it. Here's another unification. Maxwell's equations, everything in Maxwell's equations matches up with what we're showing. There's no discrepancy. So Maxwell's equations is the EM wave, Max Planck is the individual Planck coins, Einstein is the photons. So here's where we can look at a photon for real and see that it's a neutral arrangement. But within that neutral arrangement, we have a north and a south magnetic expression. So this would line up with a Evans photomagneton, if any of you are familiar with that. And also lends itself well to light being refracted as it encounters more and more equilateral Planck coins within its environment. So instead of saying what Albert Einstein would suggest is the warping of space-time due to the presence of matter, what we're saying is that matter in motion has a secondary kinetic EM field, and light is refracted when it goes through that. When it encounters those other EM waves or EM triangles, we get a refractive index. So it's a little bit different understanding, an alternative explanation to what is happening with many of the well-known experiments, many of the work, giants that have gone before us. The only difference between Max Planck and Newton is Abraham's triangles. Again, square meters per second is the units. You combine mass omega, you have Planck's constant, so it helps to rationalize that relationship between electromagnetic energy and the geometry itself at the quantum level. So Newton represents the force vectors, the forces that result due to total energy. Max Planck is the chopping up the discrete quanta, and Abraham shows that it's all based on the triangle. How humanity missed the triangle over these years is anybody's guess. Obviously, there have been some people that have tried but have not given the clarification, the differentiation that Tetryonics provides. Okay, now this is really, really important. Photons are two bosons, but in modern physics, they equate h nu and hf. They want to say that those two things are equal, and it's quite obvious that one boson does not equal two. Modern physics says 1 equals 2. We need to fix this. And that's why we're trying to get this information out to the public, because some of these confusing conundrums have resulted, and you can easily see that two bosons is a photon. And Albert Einstein even knew this back in 1913. The 0-point energy for a simple harmonic oscillator of frequency f is 1/2 hf. I think I have another version of this. So the debate if light is a wave or a particle, we wouldn't really say light is a particle. The term particle is exclusive to the tetrahedra topology, tetrons. You could call a single light a light quanta, but that confuses the situation. I like to call light a dual boson or a rhombus configuration where you have two triangles. And then you got to be careful not to call it a particle, but you could call it a light quantum if you wanted. But to avoid confusion, we're just going to say 2HV, 2H bosons, 2H nu equals 1 photon. This is an example of boson distributions, just different ways of representing same energy fields. This actually has the E field and the magnetic field partitions all throughout. And these are the the photon distributions. And you can see that here. How are we on time? We're going to probably have to skip forward a little bit, but again, all this material is freely available.
Okay, you got about it's something like 14 minutes.
Okay, thank you.
Then you got 10 minutes Q&A.
Okay, thank you. All right, the unit circle, sine waves. This is the 90-degree phase relationships I was mentioning earlier. If you look really close at the tip of this point, this is a negative charge field. We have a minimum. But right up the middle, we have a maximum E field, and then we have a minimum E field. And then we go into the plus side. We have a minimum plus. It hits the maximum right here, and then it hits a minimum. But what's happening is the magnetics, 90 degrees phase relationships. Again, Maxwell's equations, it's right there. It's all right there. I can't even believe it. I was blown away the first time I saw this. It took me weeks to recover, if not years. Here's another way of saying the same thing, where we have the observer over here, and we're looking across. As the light photon moves up the page, we hit the minimum, and then we hit the maximum, E, negative, and then we hit the minimum, which would be called the point singularity, where all the fields cancel. But right here, we have the maximum magnetic south, and then the minimum corresponds with the maximum. It just goes on and on, guys. Just a zoomed in view, harmonic motion. This is a photon, so you can also kind of see the figure 8 pattern in here, energy switching back and forth. Energy doesn't actually move around like that, but it's a good way of representing it, and the symbol's been used throughout history. It's almost maybe been a clue to this all along. So this is the single photon. This is the photon distribution when you have multiple, I think 64 in that case. Okay, and here's the main point about the standard model that I kind of started with, but here's the visual. We're done with spheres. Subatomic particles are not spheres, they're tetrahedrons, and we build them, multiple tetrahedrons. From the mathematics perspective, they both share, a sphere and a tetrahedron both share 4 pi scalar geometries, the Gaussian surface curvature, if you will. The Gauss-Bonnet theorem will show everybody that what we're saying is in fact true, if you can get your way through the Gauss-Bonnet theorem without boring yourself to tears. But obviously what we're saying is that if I hold a sphere and I hold a tetrahedron, they're vastly different shapes, but using pure mathematics, you can't tell the difference. And nobody looking at spheres in mathematical circles has ever really even thought about a tetrahedron as 4 pi Gaussian surface curvature. So this is the tetryon genesis. We start with the EM fields, and then from there we build up 4 types of tetryons. There's there's the positive side, there's 2 versions of neutral, and then there's 1 version negative. So we have twice as many neutral particles in the universe than we do charged particles. Pretty sure that jives with observation to date. So from here, I want to point out that when we get into the tetryonic materials, it's really important to get out the templates. These are made freely available. We can print them out. We use scissors, origami with quantum mechanics. It restores a tactile, intuitive understanding. We have to work with these triangles and manipulate them in our hands, in our minds, in our vision to understand some of the things that the pure mathematics has just failed to offer. There's more information in the geometrics than is in pages and pages, books and books of quantum physics. So I just encourage everybody to literally play with this origami understanding. It'll vastly increase your facility with the tetryonic materials. And it will allow you to build subatomic particles. And in time, we hope to have play sets for children to get familiar with. But we start with the bosons. We move into larger and larger fields. Any odd number arrangement of triangles is a boson. But then in the certain conditions, we get individual tetryons, which are missing from the standard model. This is the quantum of matter. Just waiting for somebody to release the release the news. I guess we can do it here, Tesla Tech Conference. So what we have with quarks is 3 tetrahedrons, and there's multiple arrangements. A particle zoo develops, and only by playing with the tetrahedrons are we going to really fully understand what's happening at the quantum level. So these are quark arrangements, and what's next over here is lepton, neutrinos, positrons, electrons. You'll notice that both of them have 3 tetrahedrons, or tetrions, if you will, but they're different matter topologies. They expressed differently. So all these little things come about, and how nobody's played with tetrahedral dice to come up with this is anybody's guess. Here's a proton. This is a stylized view where it's unfolded so that you can understand where the positives, the neutrals, the positives, all the different tetrahedrons, you can see this line right here. If I can stop it real steady with my hand. Right here, we've got a plus and a negative. It's as simple as that. The charged fascia of matter come together. This is a representation of the strong force. The weak force, quantum mechanics, is actually these 2-dimensional fields that come together with that magnetic dipole, like a photon or larger equilateral fields. The magnetic dipole arrangement is the weak force. The fascia, the strong fascia tetrahedral force is the strong. And so when we fold up a proton, we end up with 20 matter, 20 pi expressed on the outer shells, or outer topology, but there's really a total of 36 pi geometries within a proton. The same is true of a neutron, but there's a different charge arrangement. Again, by playing with the tetrahedral dice, we can come to these understandings a little bit better, intuitive feel. Neutrons and protons are the same size, and there's different masses that result, but a heavier particle isn't a bigger particle. It just has more energy in the face. So we're going to talk about deuterium here pretty soon, and there's 8 flavors of deuterium, 8 quantum levels. There's light deuterium and there's heavier deuterium, but at no point are these differences, is one larger or bigger than the other, or smaller than the other. They're all the same size, the quantum level. Here's a zoomed in view of the electron, all negative tetrahedrons. They come together at the very center, but they are repulsive around the edges. So this is a 12 pi matter topology. When we say topology in Tetryonics, we're really trying to express that there's a 3-dimensional volume tetrahedron. Typically when we say geometry, we're speaking to the 2-dimensional fields. So that distinction's another good point to make. All right, finally, he comes into the picture. His 3-phase quantum rotor is basically an electron macro scaled up. And as we know, Tesla had a vision. He could visualize these things in his mind's eye, put something together, and it would work. Here's an example of electron spinning, and why it's confusing from an observer. Every 100-degree spin, it looks like you have the exact same particle. So we're a little bit confused on what's actually happening with an electron. First, because we think they're spheres, and nobody else has identified the tetrahedral topology of the electron before now. Here's just all kind of a breakdown of the actual masses. Once you understand the value for Planck's mass, the quantum scale, you can start calculating all the values for the subatomic particles, the masses of the subatomic particles, all of them. The heavy lifting has been done by Kelvin, and now we can really play and have a lot of fun with this stuff. Wave-particle duality. Imagine that as the electron, matter, formed in a topology. Matter is invariant, meaning that after it's formed, its topology, it doesn't shrink or gain mass in itself. What's happening is matter in motion develops this secondary kinetic field, and this explains the relativistic mechanics in a different way. So as I move this electron up the page, I develop a north-south pole, or south-north, depending on which direction you're looking at, which side of the electron you're on. But the kinetic energies is represented by this right here. Kinetic energies is what? 1/2 mv squared, half of the triangle. Half of the energy is kinetic, the other half is represented in the magnetic dipole as a result of particles in motion. So the best picture I can paint for you to help with the wave particle understanding is a boat. A boat is a boat is a boat, whether it's stationary or moving at 100 miles an hour. But what happens? The faster we go, the bigger the wake. We develop a wake as we move matter. Same with an airplane. The airplane doesn't change size as it gets Mach 1, Mach 2, Mach 3, but it develops this wave. So you can see the full picture now. The half mv squared is this rhombus up the top, and the other half, the kinetic electromagnetic field, is the magnetic dipole. So it's not all that complicated, it's just different. It's kind of the same thing, just referenced differently. Okay, wave interference. As we have an electron moving to double slit experiment, what's happening is these triangles are interfering. Let's pretend that this electron hits the plate, is stopped, but it throws off its kinetic electromagnetic field and it interferes on the back panel, creates this interference pattern. So it's a new understanding to explain the double slit experiment, the single slit experiment. It's not that electrons exist in superposition all throughout the universe, and when we decide to look at them, they pop into place. That's not what's happening. Those are abstract formulations. So this is just the superpositioning, additive, subtractive phase relationships that develop as we interact these fields. Here's the deuterium nuclei that has multiple layers. So what I'm saying here is we have a light deuterium and then we have a heavy deuterium, but this is the foundation of the elements. Hydrogen is not the father of the elements. Hydrogen's a free radical. It's missing part of the topology. So deuteron, without the electron, neutronium, antideuteron. But with an electron, we're going to have matter, the foundation building blocks, and then we build these up. And as a result, a new periodic table develops that replaces Mendeleev and gives us more insight. Again, quantum insight. The periodic table of Tetryonics goes down to the quark level. We're done with the Bohr spherical model, and electrons do not orbit the central nucleus. What we see here in the deuterium is electron is half embedded inside of a proton and a neutron, but the orbitals, SPDF orbitals, are results of how those deuteriums come together and build Legos. Lego blocks of deuterium in this case. The new periodic table of elements and everything dictates that there's 120. So there's 2 elements that have yet to be named. Just a quick view. I'm going to skip ahead. Again, all this material is freely available. You're not missing anything. But I've packed too many pieces into this presentation. Periodic table, wonderful stuff. SPDF orbitals is a result of where those deuteriums and where those electrons are. The mathematics comes about, but it's again a reinterpretation. Here's the nice view. This is the new periodic table replacing Mendeleev. Again, we'll slow this down for you in the foyer afterwards. Another point of the proton-neutron Z number. There's always an equal number of protons, neutrons, and electrons in the field. Okay, Newton's gravity is a strictly convergent force, but see this equation of force? It's very similar to Coulomb's law of interaction. The reason it's similar is this relationship right here. The similarity in equations is that right there. So that's another unification of physics using triangles. We have to realize that there's interactive forces with Coulomb's law, and there's only strictly convergent forces with Newton's gravity. Dark matter is, again, these convergent forces of EM fields being mistaken for dark matter. Dark energy is the divergent forces that result, because there's literally a force that's produced. Radiant energies are thrown out into the universe. So as a Tesla Tech conference, I'm trying to squeeze this in, but Tesla was working with energy form that was at a 90 degrees phase relationship to Hertzian frequencies. Hertzian is over here. It's like a hand. It's like slapping your face versus poking you in the eye. So it's a different understanding, but it's still electromagnetic energy. Spark gap discharges produce this situation. The longitudinal energy of Tesla is simply a 90 degrees phase translation from Hertzian. Just another example, another way of expressing that. The unification Abraham's figured out Hertzian is the up and down. Tesla is going this way. Just another example. The Eric Dollards that talk about the I and the J propagation is really just this linear momentum that results. Instantaneous action at a distance. There's really a way to communicate superluminally via this energy understanding. And obviously we've been working on this for a while, and hopefully we're going to be able to deliver something like this to humanity soon. We all know we're trying to save the planet. This is where we need to go. Spark gap discharges. So anybody working with spark gaps, I applaud you. You're on the right track. Tesla spark gaps, Hertzian. That concludes my presentation. I know it was quick, I know it was fast. There's plenty more to go. That was just an introduction, ladies and gentlemen. And
Thank you very much, Richard Blankenship.
very welcome. Thank you for
We can
having
come back
me.
for questions right here. That would be fantastic.
First of all, I'd like to say I love the presentation. And I was wondering if somewhere in the material online, because I know you had to give a cursory overview of all this, is how golden mean ratio comes about, the phi.
We can show that in the equilateral tile. You start with 1, and then with the geometric expansion, you can show those spirals curving. That would be found in the mathematics, book 5.
Okay, mathematics.
And I can point you to that material, no problem. Well,
Okay.
the
Does that include like the vortex nature or the vortex energy and nature and things like that? Is that covered?
Yeah, I mean the spirals that are expressed at the macro level, yeah, it all
Okay.
applies, but just it's not vortexing at the quantum level. It's the triangles that we need to be paying attention to.
Okay, thank you.
No problem.
Well, that was astounding. I wonder if geometry is as foundational as it appears to be. If the decimal system is tightly correlated to this, I mean, have you worked any of these numbers out in other number-based systems? The mathematics should be the same if the geometry doesn't vary, and I'm just curious if...
You're right, yeah, I guess. I'm just using an algebra, basic integer number notation.
Right,
At this point, I don't know if anybody's tried to apply this geometry to other number systems specifically.
Yeah.
But you're right, as the geometry being constant should apply.
Yeah, and that could be why they didn't discover it earlier, because we didn't have a 10-base system.
I'd like to introduce everybody to Kelvin C. Abraham. He's flown all the way from Australia to support this effort. Would you mind letting me
Please.
have the mic and letting me introduce the community to this might not ever happen again, ladies and gentlemen. This literally could be is a historical moment for us. I wouldn't be here today if it weren't for my mentor.
Thank you.
I thank you so much for all the time you spent with me, sir.
No, you're welcome. Well, thank you, Richard, because you're the one that did the hard lifting today.
Tried my best.
I'm the quiet one behind the scenes. I don't do a great deal except sit in front of a computer and think hard, draw up some pictures to try and explain the connections that I see in my mind. In a nutshell, all we're doing with Tetryonics is just saying energy is an equilateral form. Planck's constant hid that form by having angular momentum and describing it as angular momentum, which we interpreted it as a vector rotation about a point rather than a triangle. You can make it as complex as you like, you can make it as simple as you like. Tetryonics at its base level is just children, myself included, playing around with triangles. We print them out, I stick them together days on end. And then occasionally I force myself to go a bit deeper into the math and make the connections that everyone's seeking. At that point, this will just grow and grow and grow as your brain becomes accustomed to the geometry, and you gain that understanding, that insight, and you change your mental patterns. You can make connections that Richard hasn't even touched on today. That there's reasons why things are the way they are in Tetryonics, why the protons have the same mass as neutrons, Z numbers. It all brings about the periodic table. It brings about a unification of gravity on the cosmological quantum scale, and it all again, comes back down to these triangles. So all I can do is thank you for giving us this opportunity to present, and encourage you to go out there, print some triangles, and have some fun.
Thank you, sir.
Well, we will definitely be keeping our eyes on this for the next few years and see where it takes the science here at the conferences.
This is Cliff Notes.
Fantastic.
That's the best we can do.
Is that available for sale out at the booth?
We can talk to this gentleman about what's
Okay.
possible there. This is just Trinity of Trinities, unifications broke down as quickly as possible. I asked Kelvin to do a Cliff Notes version once, and he just laughed. As a unified theory, it's obviously a lot of ground to cover, but yeah, we can look at this outside afterwards.
Well,
It's free. We're giving this information away.
the comment was, where can you buy it? And he says, you can't buy it, it's free.
Absolutely.
Thank you very much, Abraham. Thank you very much, Richard Blankenship.
Thank you.